Hello, everybody. My clickbaity title has worked. Fantastic. Welcome to OpenAPI. You're doing it wrong, and I would just like to thank each and every one of you individually for coming to my talk, because I don't have very much content. So, hi, Morton, thank you. Hi, what's your name? No, I'm kidding. This is a talk that popped into my head at the end of last year, where I'm still working, where we have a lot of APIs. We're an API-first company, lots of teams working on APIs that other teams will call. And mostly those are HTTP APIs. Internally, they call them REST APIs. They're not REST APIs. No APIs are REST APIs. REST was a stupid idea, and we're not doing it. Now we just use REST API to refer to any API that's JSON over HTTP. But it's not REST. It's OpenAPI. And as .NET developers, the killer burning question for all of us when it comes to OpenAPI and Swagger is, should I use Swashbuckle or should I use NSwag? And I am here to answer that question once and for all. Okay, I don't have anything against the people behind Swashbuckle and NSwag. And what they do well. And it's better than nothing. It's better than just not having Swagger for your project. But it is missing the point of OpenAPI. It's missing the point of Swagger. And I'm hoping over the next 58 minutes to convince you of that and send you away to do things differently. So let's start off by talking about what OpenAPI is, because as .NET developers, you include Swashbuckle or NSwag in your startup code for your ASP.NET Core project, and you put the attributes on things, and then something happens, and your website, your API, magically has a /swagger/UI/index.html page. You don't know where it came from, but it shows your API. If you set it up properly, it makes it possible to call your API and run test things against it. Not many people in the .NET world look at the actual OpenAPI.json file that is being generated underneath that. That's the actual documentation of your API. So let's start. We'll talk about the OpenAPI versions. So OpenAPI 2.0 was Swagger. So there was Swagger 1 and Swagger 2.0, and then Swagger 2.0, they said, okay, this is going to be a standard, we're going to call it OpenAPI, people are going to collaborate on it. And then, so the next version was not called Swagger, it was called OpenAPI 3.0. This is the current version, this is the thing that's supported by all the tooling and everything else that's out there. There is an OpenAPI 3.1, which is new and improved. And we'll talk about the main difference there later on. And there is a speculative OpenAPI 4.0, which currently has the codename Moonwalk, and we'll look at that later on as well. But for the time being, right now, if you want the best experience, you should use OpenAPI 3.0. Fun fact, this is the first time I've done this presentation where I remembered to make this slide already have everything, and remove the animation on the slide, because it used to go open and then all the versions would disappear and it would just have the use this one arrow. So yay me, fourth time lucky. So how do we implement OpenAPI? Well, like I say, in .NET, we add a bunch of attributes to our MVC controllers, or we add a bunch of .this, .that, .the other method calls on the end of our minimal API definitions. And we say, oh, okay, so this is an add, and it's a post method, and it produces 201 with a type of book, and we just fill our code with attributes. I see a lot of APIs where what they're actually doing is incredibly simple. They've got a DB context being injected, they get a record by ID, and this is a whole other talk. They then return the entity framework class so that it can be serialized to JSON. Don't do that either, but I'm not going to get into that now. So you end up with this situation where to get a quality OpenAPI description of the project, there's more lines of code given over to those attributes than there is to the functionality of your code, which is just weird and wrong. You get methods that won't fit on a page because the attributes section is running at like 30 of the things. Everywhere else, in the Node world, in the Python world, in the Ruby world, in all the other places, when they do OpenAPI, I think some Java things might now do the reflection-based stuff, but most teams, particularly in the dynamic world where it can't make inferences about types and generate JSON schemas and that sort of thing, they write their OpenAPI file by hand, usually in YAML, unless they really hate themselves, and then they build the application to match their OpenAPI.YAML file. They are handcrafted, artisanal YAML files that people maintain and source control. And I know some people sort of got YAML fatigue at this point if you're using Docker, or particularly if you're using Kubernetes, because you've got your Kubernetes resource files, and you've got your Helm charts, and you've got this and that and the other, and then you've got your CI/CD pipelines with GitHub Actions or Azure DevOps, which is another crap load of YAML. There's YAML all over the place, and you don't want another piece of YAML in your life. Just deal with it. It's always going to be all YAML files all the way down. When we get to WebAssembly running in little WebAssembly containers, we're still going to have YAML manifests for them. So it's fine. Let's just use YAML. It's the absolute worst data serialization and structuring format, except for all the others we've tried. I still remember, I've been doing this, not speaking at conferences, but I have been a professional software developer since 1990, so that's 33 years. When we first started, when I started out with Infomix 4GL and Wise terminals and SCO Xenix and that sort of stuff, we had Waterfall, we had SSADM, we had Prince2. There was a process, and business analysts would generate specifications, and then analyst programmers would then turn those specifications into code. And we actually used to say, wouldn't it be really nice? We used to use lint to check that our C was going to compile before we tried to compile it, because lint would run in about 2 minutes, and the builds used to take 2.5 hours, and we played table tennis. And we used to say, wouldn't it be great if you could lint the spec, if you could check that the spec was correct, if there was some kind of compile step that the spec could go through, because it was Word documents or it was text. It wasn't Word documents, this was 1990. They were text documents, they were just unstructured. And now we actually have a spec format that you can lint, and it will tell you if there are errors, and you can check that it's right. And it's called OpenAPI. And when we're building JSON over HTTP APIs, this is our specification. I actually see people, so they go, oh, we're going to use Swashbuckle, we're going to use NSwag to generate our OpenAPI.json file, but we need the spec for the API, so they write the spec in Markdown in the GitHub repository. And what you're doing is you're writing your OpenAPI YAML file in Markdown with headers instead of sections and everything else. And this is something we've been brought to expect in the world of .NET, and I blame WCF. I blame WCF for many, many things, including my failure to achieve Microsoft certification, because I breezed the entity frame and various components. I could not, because it kept asking me questions about the configuration files and server config and everything else. But the main reason I blame WCF is that the thing it did, 90% of the time when we used WCF, we were building a SOAP service. And the idea was that you would write your contract using C# and decorate it with some attributes, and then it would generate this shit. This is WSDL. web service definition language. And this, in 8-point font, is just 2 messages and 1 operation with an input. And so, yeah, if you actually built a WCF service that had like a service with, let's say, 15 methods on it, that WSDL file would just be impenetrable XML going on for page after page. And so in that context, yeah, okay, that was good. Nobody wants to hand maintain a WSDL file. But then we got used to this idea that these API definitions were going to be generated for us, and so we've ended up with Swashbuckle and NSwag, and also gRPC, the alternative implementation of gRPC, which Mark Gravel does. Got a lot of respect for Mark. He's a great programmer, but his gRPC implementation is from hell, and you shouldn't use it. So, why am I so against this? So your OpenAPI file, and I'm going to say it's just the YAML file, don't do the JSON way, but it's the source of truth for your team, okay? This is what you have agreed that your API should look like. And if you can have that in a single file, a single formatable, highlightable text file that you can all compare, and if you want to make changes to the design of the API, you can do it in one place, and you can view it without having to clone and build and run the application so that you can actually get the JSON file out of it. That can be your specification. That is what you have all agreed. This is the key point. If you are using Swashbuckle or NSwag, your design and your implementation are the same thing. If you want to change the design, you have to change the implementation. There's no 2-step process. Now, for some things, if you're working on a quick and dirty API and it's just you, maybe that's okay. But, you know, hands up if you are actually just working on a quick and dirty API and it's just you in your day job. Hands up if you're part of a team working on an API. Yeah, there we go. Hands up if your arms don't work. No. But yeah, you sit around and you argue and you say, this should return this type of object, it should have these properties, it should have this list of other objects inside it, and then we need to support a get and a put and a post, and we should have a get with a list and a get with an ID that gets a specific one, and maybe we want a way of querying it, and posts should return 201, and puts should return 202. No, they shouldn't. They should return a 201 if it's created, or a 200 if it was already there and we've updated it, and no, it shouldn't. It should return a 204, no content. 90% of the meeting will obviously be which variant of a 200 return code you're actually returning. But when you have decided and agreed it, it goes into your OpenAPI.yaml file. Okay? Didn't sort that one out. Better description. I have no idea how to mess with the animations on PowerPoint. But I can build APIs. So, it is a better description of your API than can be generated by NSwag or Swashbuckle. It is theoretically possible if you know the magic incantations and all the attributes and all the extension methods and all the options that you can put into the startup code to set almost every part of an OpenAPI description that can be set. It's just, it gets really difficult for some of them. And there's other things you can do in a YAML file, like, for example, YAML files support comments. And I haven't found anything in NSwag or Swashbuckle that will let you add comments into your output JSON or YAML, well, certainly not in your JSON, but into your output YAML file. And we can do automated documentation of this as well, and I'm going to show examples of that later on. And when I say documentation, I don't mean SwaggerUI, I mean some actual really nice static documentation files that you can publish that will then get people off your back and stop saying, hey, how do I call this from curl, how do I call this from Python? So this is gRPC. Actually, this is just protobuf. The way protobuf works and gRPC works, this is cross-platform. It's supported by almost everything. And you write a proto file. And I've been doing a workshop for a few years now on how to do gRPC in .NET using this proto file approach. And you define your messages and you define your services. And then the compiler generates stubs for those assets. So it generates the classes for the messages, and it generates a base class for the service, and then it you can use that, and all the serialization code is pre-generated, and so it works really well with native IoT and that sort of thing. But you can see here, this is the money type. This is from Google's public APIs that they use for things like AdSense and DoubleClick and so forth. And there's no decimal type in protobuf. They have double and float, which obviously isn't great for money. And so they have this money type, which has a currency code and a units and a nanos. And this is the file that they publish. If you download money.proto from the Google APIs site, and this is it. And you can see it's got comments in here. It's saying, okay, string currency code, telling you that it's a string is not particularly useful. Telling you that it's defined in ISO 4217 means you can go and find a pirated copy of ISO 4217 somewhere, because ISO charge for access to their bloody standards. And then it explains that the whole units of the amount and the nanos of the amount, it tells you how those are working. You can put comments in there. And you can't do that if you're using NSwag or Swashbuckle, but if you're writing a YAML file by hand, you can put as many comments as you like in there. So I mentioned earlier that I think the majority of .NET developers, and by the way, if you're already doing this, then the title of the talk was wrong, and I love you, and you're awesome, and carry on doing it. But if you're arguing with somebody, then you can point them and go, look, Mark Rendle says you should do it this way, and so that must be true. But yes, if you're using Swashbuckle, if you're using NSwag, there's a very good chance that you don't have the faintest idea what's actually in that file that it generates, whether it's JSON or YAML. And so we're going to take a look at the actual structure of OpenAPI and how you would build it out. So we start off at the top. We have kind of like our header, and we're telling the text editor, essentially, at this point. This is OpenAPI 3.0, so use those linting rules and IntelliSense and so forth. And then we have an info section. There's a bunch of stuff that can go in here, but we've got a title and a version. That's kind of like the bare minimum. And then we can put our contact information in there as well, including my email address, which is now on YouTube. That's going to be fun. And I'll just draw attention to it in case anybody didn't notice. And then we can define tags as well, and we'll come back to tags in a little while. And then the top level kind of set of items in an OpenAPI document is your paths. So we have a paths section, and then we just put in the URIs. So here we've got /red/books, and we say this has got a get method on it. And that is the HTTP method, so you would have get, put, post, patch, delete, etc. Operation ID, sadly optional. Your OpenAPI file will lint perfectly well without an operation ID, but you really should put one in there. It's very helpful. We have a summary, and you can actually put Markdown in there. You can tell it, do the YAML thing for a multi-line string, which I think is a pipe, and then you just do text following that. And so you can write as much as you want about what this method is doing, what this endpoint is doing. We say which of the tags this is part of, so this is part of our books tag. And then we define our responses, and we say, okay, so we've got a 200 response. We're going to put that in quotes because YAML can do weird things if you use numbers as property names. So we'll put 200 in there, and we'll say the description of that is okay. And then we drill into our response. So we can specify the content of our response, and we can actually specify different descriptions of that content based on media types. 90% of the time, you're just going to say application/JSON. But if you're working in a place where you've got Java programmers in the early 2000s are calling your service, then you could put application/XML or some other format in there as well. And then we can specify a schema. And in this case, to make it fit on the screen, I'm just using a reference. And we can also specify examples. And that's really nice as well. That means that in the documentation, when it's generated, instead of going, oh, this one's a number 11111, this one's a string quote, it will actually use realistic-looking examples of your domain. Schema. Schema is basically JSON schema. Okay, so we have schema, type object, properties. So it's written in YAML, but it's JSON schema, and YAML is JSON, but without the quotes and curly braces and with significant white space. The underlying representation is essentially the same. You can use JSON inside YAML. You can use JSON arrays and all sorts of weird stuff. But we have schema, so the type of this is object. It has some properties. ID, title, and author, those are strings. Finished at is a string, but the format of it is a date time because JSON doesn't understand dates. So we have to say this is going to be a date time, so that means that'll be an ISO 8601 date format on there. And we can put that in line, or we can put it somewhere else, and we can reference it. So yes, and it's JSON schema, but. Okay, so the difference, the primary difference between OpenAPI 3.0 and OpenAPI 3.1 is that in 3.1, it actually is JSON schema. It follows the same rules, the same validation, same everything else. In 3.0, it's kind of a subset, bit of a superset, call it a variant of JSON schema. It's pretty much the same. Unless you're doing very weird things, you're not going to run into issues with that. Okay, and then we have our parameters that are being passed in to our methods. And so here we've got our path is /red/book/ID in curly braces. It's the same format as is used in almost every routing system, certainly the same as is used in .NET or ASP.NET Core. So this actually gets the details of a completed book, but we have our parameters list here. And we see name ID, so that's linking it to that ID part from the path there. We tell it it's in the path, and you can also say in body or in headers in there as well. And then we can put a schema in there. Since this is in our path, it's obviously just going to be a simple type like an int or a string. But if it's in the body, then it could potentially be a full JSON schema. Is it required? Yes. And that's how parameters work. I thought I had something else to say there, but I don't. Okay, so requests. If we have a post operation, it's got a request body. If we have a put operation, it probably has a request body. And so here we can have a request body. And we can specify the content and the application type and so forth. We can have a schema in here. We can also have a required section on our object schema here that says you have to put in title and author. Otherwise, we're going to send you a 400 bad request response. And so we can put that in there as well. So an API, if I've got my sort of done.dat API, which is what I'm using as an example here, done.dat is, I don't like to-do lists because they're incredibly stressful and it's too much pressure. So I'm creating a done list. So after I've done something, I can just arbitrarily go, I did that. But I haven't got anything saying, oh, you need to do that. I just go, yay, I have succeeded. So I get all the gratification and benefit and endorphins of marking something as done, with it never having been there marked as not yet done. So this all comes from that. So this is kind of like add a distance for a run or a walk or something. And obviously the properties of a distance would be a title and an author. And I didn't just completely screw up my code samples. one day I'll give this talk and I'll have fixed all this instead of just calling it out like an idiot. But today is not that day. So yes, but like one of the things in there is books, which do have a title and an author and a date that I finished it at. And if I get a list of books, then the response type, the schema is going to be book. If I get a single book, then the response type is going to be book. If I post a book, the request type is going to be book. I don't want to repeat that all over the place. And so we have components. And I'm going to switch over at this point to Visual Studio Code. And I'm going to move this onto here. And we're going to close that. And we're going to zoom in. OK. So this is, can you see that at the back? It's a big screen, should be able to. So yeah, here we have our books and our authors and our distances and our users. And so you can see here that I've got this $ref list of books and components examples lists of books. Right down at the bottom of this API here, I have a component section. So this is the other top level section. You have info, paths, and components. There's one or two others, but these are the main ones. Within here, we have various different types of reusable components. So we have examples here, and we can see that list of books, the value of that is 2 objects, each with an ID, a title, and an author. And we have a single entry for Hitchhiker's Guide to the Galaxy and Mort. And then we have a schemas section, and we have a book here that has an ID and a title and a finished at. And we have a new book which just has a title and an author, and we have our list of books which is an array, and we can reference things inside here, and so on all the way down to the bottom there. Okay. The things that we can stick in components are these: schemas, so our JSON schema objects, responses and request bodies. We can put those in there so we don't have to keep redefining a response. Parameters, so if we've frequently got an ID parameter, for example, and we're using GUIDs across our entire system for our IDs, then we can define an ID, which is a type string, and format UUID, and then reuse that across the entire system. Headers, so location headers or content type headers, that sort of thing. Security schemes we'll take a look at in a minute. Examples, which are really good and make your documentation look a lot better. Links and callbacks. I've not used those in Anger, but they're in there. I'm not 100% sure what they're for, but if you need them, I figure you'll figure it out. So this is how we do components. We have that component section at the end of the file, and then we reference those using a $ref property underneath. So if we say we're referencing a schema, we say schema : and then a property inside that that says $ref and points to where the actual schema object is. So I get confused with that sometimes until I've sort of got a couple of examples, and I go sort of content application /JSON and then $ref right away. No, doesn't work. It doesn't know what I'm referencing. The other thing you can do, and as you get to a point where you've got a bigger API and more people working on it, is you can actually reference external files. So you can dump your schema into individual YAML files or JSON files. You can reference these as JSON as well. And then you can just import it in. So if the reference starts with a pound symbol or a hash symbol, if you're not American, why did I say pound symbol? My God, I'm British. That's not a pound symbol, it's a hash or a sharp. Anyway, so that will look in the existing file under component/schemas. If it doesn't start with a hash, then it will look for an actual file with a path relative to the current file. So one of those things that I had in that list of components is actually security. This is something that I really don't see often enough in Swagger UIs for people who are doing Swashbuckle or NSwag. It's quite tricky to set it up and tell it how to do authentication. So in our component section, we can have a security schemes section, and then we can define schemes within that our application supports. So I've got my API, it's using auth0 to let you authenticate because I am made of money. Sorry, auth0. But no, it could be identity server, could be anything else. But I can say the type is OAuth2. There's a few types that can go in there. And then I can specify the flows that are supported. So we've got implicit, where it will redirect you over to this authorization URL. And this specifies the scopes that are going to be requested when you go over to that. And we also have client credentials, and we have a token URL that you can go to with a client ID and a client secret and get back a bearer token that you can use to access the API. And then I can, actually on the top of my OpenAPI.yaml file here, another top level thing, and I can say security, and the security scheme for this is auth0 and then empty array. So it is possible to put more things in there, but I just want the property name. In YAML, the best way to kind of just have a key that just means something by its presence but doesn't have a value is to use an empty array for some reason. Okay. Your API is going out there into the world and people are going to call it. And if there's one thing I've learned about people in my 50 years of existence, it's that, so I can go two ways here. They're stupid is the mean way of doing it. It's, no, people make mistakes. And they're going to call your API, and they're not going to have formed their request object properly or their URL properly, or something is going to be wrong with the requests that they send you. Or maybe you've made a mistake and something goes wrong and an exception gets thrown. Or maybe you're relying on an external service like a database or a Redis cache or a blob S3 storage or blob storage. All sorts of things can go wrong, and you need a way to communicate to the person calling your API that something has gone wrong. If somebody has sent you an object which has got sort of in total with nesting and everything else 80 properties, okay, and you're trying to, you validate it and go, are all these properties okay, and one of them isn't, and your response to that person is 400 bad request, no content. That's not very helpful. So there is a sort of standard. It's kind of, I'm not sure it's actually maintained by anybody, but it is agreed upon. There's a standard format for returning problems in JSON. The MIME type for it is application/problem plus JSON. And it looks roughly like this. We have a problem details. It's got an object. We say as a type. So what type of problem is it? Is it an internal server error? Is it an external provider error? Is it something wrong with your object error? We have and that would normally, so the purists would say that should be a fully qualified URL. Ideally, it would point to an HTML page that describes that type of error. Nobody does that. We have the title and the detail, so that's where you put in the text for the user to read, the consumer to read. We have the status, that's the HTTP status code. We have an instance, which is like a trace ID, so like activity.current.id, you can put that in there. And then we have objects, which is essentially a dictionary, but in JSON, a dictionary is just another object with properties and so forth. And then we have extensions, which is where you can put whatever the hell you like. And we have an example of this here. So this does actually point to an RFC 7231. One or more validation errors occurred, and 400. We've got our trace ID in there, but we've also got in errors. The way to fill this out if it's a bad request is for each property that there was a problem with, you use that as a key, and then you put in a string list, a list of strings of things that were wrong with that property. So maybe it's really weird when you can have more than one problem with the same property. I struggle to think of scenarios for that, but you could have more than one problem with it. You go, this is too long and too short. Make it exactly the right length. So yes. Okay. So let's jump back to this code here, and we can see, if I look at post, we've got a 400, and it will return this 400 bad request. So we can go up and we can open, we've got a responses folder here, and we've got a 400 bad request, and this content type is application problem plus JSON, and we have a validation problem details YAML, and then we can specify this in here and say what's going on there. I also have a 201 created, and if we return, according to proper HTTP API things, if you have created something, drives me nuts that the created method in an MVC controller, you can pass in the object and it'll serialize it back into the response, which is not really the way you're supposed to do it. You return a 201 created, and then you set a location header and say this is where you can do a get if you want to refetch that object and find out what ID I assigned to it magically, or that sort of thing. So in headers here, we just have a location header, and we can see this is the absolute URI of the created record, and it's a string, because of course it is, it's a header. Okay, so yeah, we have this problem details, and then any request that has a post or a put or anything like that has the potential to return problem details, except for some reason this one. Okay. All this code is on GitHub, by the way, so don't worry too much if you're not managing to write it all down as I scroll through it. Okay. So that's OpenAPI 3.0. That's where we are at the moment. When I went on Twitter and said, I'm doing a new talk to tell .NET developers to stop using Swashbuckle and NSwag, Daryl Miller, who is on the OpenAPI working group, sent me a DM and said, yeah, good luck with that. But he pointed me at some stuff that they're working on. And one of the things they're working on is OpenAPI 4.0, which is currently called Moonwalk. And it attempts to fix some problems with OpenAPI 3.0. And it does. It fixes them in a nice way. The key thing here is that we have paths, and we have red/books, and we have our tags. But then below that, instead of having get, put, post, delete, whatever, we have requests. And then what used to be operation ID becomes a top-level key in our YAML. And then within that, we specify that the method is get, and the description and responses and everything else is pretty much the same. Except in responses, instead of using the status code, we say there is an OK response, which will be status 200. There may be other responses. The key difference here, and the thing that this recognizes that OpenAPI 3.0 doesn't recognize, is that you can have polymorphic endpoints. So you could have an endpoint where you post something to it, and if you post object foo, then it will do one thing, and if you post object bar, it will do another thing, and if you post object wibble, it will do another thing. And those three things will all return different responses. Now, in OpenAPI 3.0, you say post, and then you can specify multiple possible content types that they could post, and you could specify multiple possible response types that it will return. But there's no way of saying, If you post this, you'll get that. If you post this, you'll get that. And if you post this, you'll get that. OpenAPI 4, Moonwalk, lets you say you can post to the same URL different objects and the behavior will be different, and it allows you to describe that. And the response is OK there also allows you to say, OK, I'm going to have 3 different ways that I describe a 400 bad request to you. So I'm going to separate out whether it's a server error, an external dependency error, or you've done something wrong. And you can name those and you can give them different descriptions. Okay. There's some really neat tooling out there for OpenAPI for people who are generating this stuff. There's SwaggerUI. That's the thing that everybody's seen. Okay, that's the thing that Swashbuckle and NSwag magically add to your API application. SwaggerUI is great. It's still called SwaggerUI. It's not called OpenAPI UI because Swagger is still a trademarked name belonging to SmartBear, and so the UI is still called Swagger. The underlying document is called OpenAPI. So we all know about that one, but then there's Redoc, and this allows you to do interesting things with your YAML or JSON files from the command line, like, for example, bundling. So you can, if you've got, like I have in my sample code, everything broken up into lots of different files, you want to bundle that, compile it into a single file for deployment along with your website to drive SwaggerUI. SwaggerUI won't follow links between files apart from anything else. And so Redoc allows you to bundle everything into a single file. It also will generate a YAML file and a JSON file from the same source as well. Widdershins and reslate is a way of generating documentation Redoc will also generate static documentation files, so it's basically an HTML file with some inline CSS and JavaScript that then loads your JSON file and turns into a lovely documentation page. Widdershins and reslate is another way of doing that. It's sort of Python-y, Node-y sort of solution. And then there's elements, and I'm going to show you elements in a minute because I love elements. It's great. In terms of actually working with this stuff, VS Code, there are multiple extensions for working with OpenAPI.yaml files. The one that I recommend is by 42 Crunch. Okay, they're all okay, but the 42 Crunch one has just been the most stable, provides the best IntelliSense, provides the best red squiggles, all that sort of thing. If you're using JetBrains Rider, you just have OpenAPI support is built in out of the box. And also, if you're using JetBrains Rider, if you've actually got an OpenAPI file in your project, it will do magical things. It lights up, it generates test code for you. It does all sorts of insane stuff. It generates like a Postman style thing for calling your API just from having that file there. So bundling, Redocly is an npm package, and so you do npm install -g redocly and wait while it downloads the internet somewhere into your valuable C drive where you don't have very much space, and then you can do this from the command line. So that will follow all the links, and then it will embed any referenced files. It'll just move those into components, rewrite those refs so that you have a single file for deploying to your application. Okay, so I said I was going to show you elements. I'm going to show you the other thing that I really like about this. I'm going to zoom in because that's ridiculous. Okay. This is the code, so note that down. That's where you can get the stuff from. The slides will be in there after the talk as well. I'll do that before I shut up and leave. So yes, if you're JSON file, if your YAML file, if your JSON file is generated by Swashbuckle or NSwag, and people go, how do I get the documentation for your site? And you go, clone this, run it, or go to the actual thing running in production and look at the SwaggerUI, and that's the documentation. If you have it as a source-controlled item, which you should be doing anyway, because as I say, this is your agreed design and your source of truth for your project, for your developers to be working from. But if you have that in your GitHub repository, you can just do some very simple GitHub actions, and I mean simple, and you can generate the documentation into GitHub pages, and then when someone comes along, you can actually, on your README file, say, oh, look, here's the documentation. And it's not a complicated GitHub action. It is, so you have to go through the thing of saying, I'm going to show this in code instead because that looks horrible. No, I don't. Go away. Right. So this is our GitHub workflow. We need write permission because we're going to be modifying a branch, and we have build and deploy. Install and build step, we can use npx. So Node is pre-installed on all GitHub workers, so we can use npx, which says don't actually install this package, just download it, cache it locally, run it, and then trash it. So we can say npx redocly/cli bundle OpenAPI blah blah blah, and then we can use this deploy GitHub action, which James Ives, whoever he is, wrote, which will take our dist folder from the current directory and copy it into a branch, the GitHub pages branch in this particular case. That's it. That runs on every check-in. And then if I go back to here, and I can show you the two documentation options. So I'll show you Redoc first. Okay. I hope that looks better on the big, does that look better on the big screen? Because it looks like hell down here. It's sort of readable, isn't it? But yes, so this is Redoc, and we get a lovely sort of set of documentation here. We can go to different sections here, and remember earlier on I mentioned tags and why they're useful. So SwaggerUIs that are generated by NSwag or Swashbuckle, unless you know that there is a tag attribute that you can add to controllers, for example, or methods, action methods, it'll just be a massive list of endpoints. If you put tags into your OpenAPI, it breaks those down into sections in Swagger, so you can see what the books bit does, what the users bit does, what the distances bit does, and everything else. And the same thing when you have your Redoc code here. And so we can drill that. We can see that the authorization for this is auth0. We can see that's the flow type there, client credentials. There's our token URL. There's our implicit authorization URL. We have our response, which is going to be application JSON, and it's going to be an array of these object types. And we have all the things that we can do in there. So that's Redoc, and I was quite chuffed. Oh, and over here on the right, it's got sort of sample JSON for each of those methods. So this is the payload that we should be sending. Proper examples, because I actually took the time to put proper examples in there, so it's not just randomly generating strings. So I thought that was quite nice, and then I found elements. Elements. So elements. This uses web components. It's by Stoplight. It is open source, and elements breaks things down like this. It looks quite a lot like Redoc until you go into, let's say, books, and let's say add a completed book here. Okay, so we can see over here, Our auth is going to be token, and our body, this is an example thing. We actually have send API request. If I authenticate using this, and because I've put the URL to authenticate with auth0, it will go and do that bounce around URL. Not going to do it right now because auth0 gets weird about conference Wi-Fi. And we can see it's got roughly the same set of things here. We've got the responses that it might return and everything else. But then come over here and we go, okay, so here's how to send a request to this API from JavaScript using XML HTTP request. Here's how to do it using fetch. Here's jQuery, something else. Here's how to do it from Python in Python 3 or using requests. Here's how to do it in C# using HTTP client or using REST sharp. So if I want to call this using an HTTP client, I can just, oh look, there's a copy button. So people can copy and paste wherever they're using your API from. They can copy and paste the code from the elements documentation into their application, and they can call your API using that. I love elements. It's fantastic. So there's a bunch of stuff that I'm kind of noodling with and building to make this work properly. The one that's kind of out there and you can do things with it is OpenAPI.web. Because obviously, if you're just going to hand code your OpenAPI file and then dump it into your project, you need a way to serve that out. And so OpenAPI.web lets you embed that as a static resource, and then it will serve it out. And it will also serve the SwaggerUI HTML and JavaScript and CSS. It will also serve either Redoc or Elements, or both, if you want both. I'll show you how that looks in the startup code for this project. So if we go to API here, and src, and program, I've commented out the Swashbuckle code. So we no longer need an endpoints API explorer, and we no longer need SwaggerGen. We just have our normal stuff there. We no longer need use Swagger and use SwaggerUI. We can just replace those with this. Okay, it's big. I'm working on sane defaults and other ways of doing this. So you specify the assembly that's got the resource in it, and then the path to the resource in that assembly. So that's the embedded resource. And then we can put some OpenAPI options on there. We can say this is version 1. The UI path prefix is Swagger. The JSON path is going to be here. The YAML path is going to be here. If what you embed is YAML, it will convert it to JSON and vice versa. So it will serve both kinds. And then I can say I want elements documentation by specifying this element section and just saying swagger/v1/docs. And then that returns a normal routing sort of app thing, so you can put on allow anonymous and calls and anything else you might want to do on any of the endpoints that are generated in there. Okay. Stuff that I am working on, some analyzers. So at the moment, the big argument that people sort of come back with is, yes, but if I want to change my API now, I have to change it in 2 places, and what if they get out of sync? Yes, I can sort of see that. I mean, you know, just don't. You're a grown-up. Do things properly. But also, if your design and implementation are both in the same place and they're wrong, that just means you're wrong twice in one place. That makes sense? Yes, it does. But no, I'm working on some analyzers that will look at your OpenAPI.yaml file and then say, are you actually implementing that? Can I find where you're returning a 401 or a 403 or a 404? Can I, does the object that you're accepting is the body of this request actually match to what you specified in the schema, and can I put red squiggles under there, and can I generate warnings that you can then set as errors so your web application won't build if it doesn't match the specification. I think that could be quite useful. I'm building a bundler in .NET so you don't have to install Node to bundle your YAML into a single file. I'm working on a test thing where you can write the tests in YAML so it looks quite a lot like an OpenAPI file, and then it generates XUnit tests based on that. And then the really fun one, and the thing that I think is potentially the most interesting, is some code gen. Because remember I showed you the proto file and the way gRPC works, and it generates the model classes and the stubs for the service class. So you get something, you maintain those proto files, but you get something in exchange. It's the other way round. You're not sort of generating the information from the code, it generates code from the information. And so I started looking at ways of doing that. Now, there are quite a few tools out there for things like Node and Python and so forth that you can say, here's my OpenAPI file, generate me a Flask application, and it will do the skeleton. It will sort of scaffold out that application for you. But it'll do it once, and then you change the specification, it won't update it can't rewrite the code that it's already written, so it's a kind of use once thing. So what I'm working on is something that will generate the model classes for you, and then generate a base class, very much like the gRPC service base class, and then you implement that. And then there's a library that will hook it up using minimal API, so it'll run just in a Docker container or as a service on app services or whatever else. But also another package that will hook it up to Azure Functions, and so it'll generate functions for each of those things. Another one that will hook it up to AWS Lambda and make this open so that people can get it to hook up to whatever they want. Then if you change your spec, it regenerates the base class and potentially the model types, and then if there's a breaking change, your application won't compile, and you'll have a pretty good clue that you should be calling this version 2 as well. So that's something I'm working on too. I'm very happy to talk more about this. I'm around for the rest of the day. I'm doing the lock note at the end of the day. So if you've got any questions, then please grab me outside rather than coming on here, because it's weird standing up here and answering questions. But yes, have I changed anybody's mind? Is anybody going to go back and try doing this? I suck. Who's going to carry on using Swashbuckle or NSwag? Yeah, well, baby steps, baby steps. I'll get there in the end. That's it. Thank you very much for listening to me, and I will see you at the end of the day. Cheers.